Hello friends. In this video, we are going to study about what is an inductance. We will study that how the inductance is defined, how we can measure the inductance, what is the unit of inductance and the various types of inductors and series and parallel combination of inductors. So let us start with our topic. Inductance is defined as the property of a material by virtue of which it opposes any change in the magnitude and direction of the current flowing in a conductor. So just like the resistance, when we define resistance is the opposition to the flow of current, okay? But inductance, it is the opposition to the change in the direction of the current or in the magnitude of the current. So suppose that if it is the conductor and in this conductor the current is flowing, that is I. Now if there is any change in the magnitude of the current or in the direction of the current, suppose that first the current is flowing in this direction, now the current is flowing in the opposite direction. So if there is any change in the magnitude of the current or direction of the current, then this material is going to have a property, that is inductance, which is going to oppose this change in magnitude and the direction. Also, we can define the inductance as the property of the coil We can also define the inductance as the property of a coil in which EMF is induced because of variations in the flux. Suppose that we are having a coil. In this coil, the current is flowing. Okay, due to the change in the direction of the current, there is a variations in the flux, and due to variations in the flux, an EMF is induced in the coil. Okay, so in this coil an EMF will be induced, and we can say that the coils in which the EMF is induced, those coils have the property which is called the inductance of the coil. Okay, so this inductance is generated whenever there is a change in the current flowing, in the change in the direction in the current flowing, whenever in the coil EMF is induced due to variations in the flux. So this is how the inductance is being defined. Now this inductance is added in the coil or in a circuit with the help of an inductor. So we can say that the materials which are having the property of inductance, those materials are called the inductor. So inductance is always added in a circuit through the inductor. Okay, just like resistance is the property of a resistor, so inductance is the property of the inductor. So what is an inductor? Inductor is just a coil of wires. Okay, suppose that we are having simple a straight wire is there, and we have pressed that wire so that this wire forms the shape of an helix. Okay. So there are a number of turns in this wire. So this forms the coil, or we can say that this is the inductor. So inductor is current I starts flowing. So due to this current, a magnetic field is going to be generated, and this magnetic field is going to induce an EMF in this coil. So when current starts flowing through the inductor, then an electromagnetic field is being formed. Now this electromagnetic field is going to change its direction whenever this current changes its direction. Suppose that first the electromagnetic field is generated from left to right. Now as the current changes its direction, the magnetic field also changes its direction. Suppose that now the current is flowing from right to left. So magnetic field generated in this inductor is also going to change its direction from right to left. Okay. So as we have discussed that whenever there is a change in the direction or the magnitude of current in a conductor, then an uh, inductance is going to be generated. Okay. So, as the current changes its direction, magnetic field is also going to change its direction, and this change in the electromagnetic field is going to induce an EMF in the coil, or we can say a voltage is induced in the coil, and the magnitude of this voltage is given by the equation V equals to L di by dt. This V is the voltage also, or we can say it is the EMF also. We can represent it by E, or we can represent it by V. So V is equals to L di by dt. That is the EMF which is induced in the coil, that is given by this equation. So here in this equation, L is the inductance, V, or we can say E, is the EMF or the voltage induced in the coil, and I is the current flowing through the coil. So from this equation we can define the inductance as here we know that the voltage, its unit is volts, the unit for current is amperes. So we can define inductance as, the unit for inductance is Henry. So 1 Henry can be defined as So 1 Henry is defined as the inductance of the coil when 1 ampere of current flowing through the coil induces an EMF of 1 volt in the coil. Okay, so 1 Henry is the unit of inductance and it is denoted as H. Volts is denoted as V, amperes is denoted as A, and Henry is denoted as H. So this is that how we can define the inductance. Inductance is the property of an inductor. What is an inductor and what is the unit of Henry? Okay. Now, from this equation, if we see that voltage or EMF, it is equal to L di by dt. Now, suppose that we know that the inductance is the property through which the coil, it opposes the change in the magnitude and direction of the current. Okay. Now suppose that in the circuit the current is being constant. So if current is constant, then voltage induced will be 0. Because we have defined the EMF or the voltage induced as L di by dt, that is the rate of change in the current, and if current is constant, current is not changing, then no EMF will be induced in the coil. So if we take the case of steady current or DC current, that if in an inductor DC current is flowing in the circuit, then the inductor will behave as a short circuit coil. Okay, because at that time the no inductance property will be there, so inductor will act as a short circuit coil. So in the circuit, suppose that it is having the inductor and here a battery is connected with it, which is providing DC current. So this inductor will act as a short circuit coil. Okay. Now suppose in the DC current, if there is any change in the value of the current, so due to a very small change in the value of current, then inductance will appear across the coil. Now if we take the case that in that equation V equals to L di by dt, if we put dt equals to 0, earlier we have put di, that is the change in the current, as 0. Now we have put that dt is equals to 0. So at that time we see that there is a if there is minute change in the value of the current within 0 time, means that no changes in the time has taken but the current has changed suddenly. So due to that minute change in current, there is an infinite voltage which is produced around the coil, in the coil. Okay, so this cannot happen because the current cannot abruptly change. So as soon as the inductor is connected in the DC circuit across a DC battery is there, so there first of all the inductor, it will act as an open circuit. After that it will become as a short circuit coil. So that was the voltage across the inductor, that is V equals to L di by dt. So using this equation we can find out the power absorbed by the inductor. So power is what? If we define DC power is equals to voltage into current. So we have the value of voltage here from this equation. If we multiply it with the current, we can get the equation for power. So P is the power which is equal to V and I. So V is what? L di by dt multiplied with I. So L I di by dt. And the unit for power is watt. So this is how we can measure or calculate the power which is absorbed by the inductor. Now using the power we can find out the energy also. So energy absorbed by inductor will be, if we integrate the power over a short period of time, then we can get the energy absorbed by the inductor. So if we define energy by W, then W is equals to integration of power for the time 0 to t. So now in this equation, if we put the value of power, then what is equals to integration of 0 to t? Power is what? L I di by dt here multiplied with dt. So integrating this, we will get half L I square. So that is how the energy absorbed by the inductor is defined, and we can calculate it by using this formula. So power is given by Li di by dt and energy is given by half Li square. So from these two equations, it is clear to us that an inductor is an energy storage element. Okay, so we can this inductor, it mostly find its applications in the fields where it has to be used as an energy storage element. Now if we see the various types of inductors, then we can classify the inductors on various categories, on various bases. Okay, criteria are there like size of the inductor, core material which is used, type of windings. So on these criteria we can classify the inductors. So here let us see that what are the types of inductors on the basis of the core material used. On the basis of this, inductors are classified into ferromagnetic or iron core material. Means if for the construction of the inductor is made up of either the iron core or a ferromagnetic material, then it is called as ferromagnetic or iron core inductor. Second type is air core inductor. Toroidal core inductor. Laminated core inductor. And powered core inductor. So these are the various types of inductors based on the core material used. Now these inductors are connected in an electrical circuit, so they can be connected either in a series combination or in a parallel combination. So let us see that how the resultant inductance can be calculated for a series and parallel combination of the inductor. First, let us see the series connection. So suppose that there are three inductors which are connected in series. Series means back to back three inductors are connected with each other. One end of an inductor is connected with the one end of another. So in back to back combination, they are connected with each other. This inductor is having the inductance value as L1, this is L2, this is L3. And we have to find out the resultant inductance between the points M and N. So LMN is given by L1 plus L2 plus L3. How we come to this equation? Let's see. We know that in the series connection, the current remains the same. So in this circuit, if current I is flowing, then same current is flowing in all these three inductance. Whereas the voltage, suppose that if the total voltage is V, then voltage is divided between them, that is V1, V2 and V3. So if from this equation, if we get that total voltage V is V1 plus V2 plus V3. Now, if we define the voltage across one inductor, then V1 is given as L d I by dt plus L2 di by dt plus L3 di by dt. And what is total V? That is V voltage across these points M and N. That will be Lmn di by dt. So from this equation, if we take di by dt as common, then it will be cancelled and we are left with this equation. Lmn is equals to L1 plus L2 plus L3. So in this way, we can say that whenever we want to find out the equivalent inductance of the inductors which are connected in series with each other, then it is given as L equivalent equals to L1 plus L2 plus L3 plus in this form. Means all the inductors value, it will be summed up. Their algebraic sum will be equal to the equivalent inductance. Now if we come to the parallel connection, in parallel connection, the inductors will be connected like in this way. The inductors are connected with each other. Okay, means one end of all the inductors is made as one point and the other end of the inductors is made as a second point. Okay, all will be connected in parallel with each other. So in this, the equivalent inductance is given by Lmn is equals to 1 by L1 plus 1 by L2 plus 1 by L3. How we come to this equation? We know that in the parallel connection, the voltage remains the same, whereas the current is divided. So voltage is V and current is I1, I2 and I3. And the total current I is equals to I1 plus I2 plus I3. So from the inductor equation, V is equals to L di by dt. So current will be defined as V by L. So if we write here, it will be V upon Lmn, V upon L1 plus V upon L2 plus V upon L3. V can be taken as common And if we see this, we will get this equation. So here we will get, sorry, this is 1 upon LMN. Okay. So from this equation, we can conclude that if we want to find out the equivalent inductor of the inductors which are connected in parallel with each other, then it is given by 1 upon L equivalent equals to 1 upon L1 plus 1 upon L2 plus 1 upon L3, and in this way all the inductance value is given. So this is how the series and the parallel combination of inductors is solved by using the equivalent equations. Now comes the applications of inductor, that in what fields of electrical and electronic areas we can use the inductors. The first application is that it can be used as an energy storage element. This inductor, it is used in electronic equipments like in radios. Also, it is used as an electronic testing instrument. For the testing of the instruments, this inductor is also used. Also, it is used in sensors, transformers, motors, and in filters. So there are various applications of inductor, but its main application is for the storage of energy, because in the inductor magnetic field is being generated and that magnetic field is going to store the energy. So its main application is as an energy storage device. So in this video, we studied that what is an inductance, how we can define the inductance, how inductance is measured, and what is the unit of inductance, how we define 1 Henry, then what are the various types of inductor, then we see that how we can solve the series and the parallel combination of inductors, and in the last we saw the applications of the inductor. So I hope that this topic, what is an inductance, is now clear to you. Thank you.